Hi everyone, we are going to solve maximum building height question from lead code today. This is marked as lead code hard, and the way in which we are going to approach this question is using constraint propagation with greedy approach. So before we begin, let's first understand what this question actually is. So this question tells us that let's say we have n number of buildings and we want to build n new buildings in a city. Now these n buildings are to be constructed in a single line, and there are some rules. We'll come to the rules, and there are some restrictions, and the restriction says that it's a 2D array in which every 1D array consists of two elements, which is like ID, which is like the building number, and the maximum height of that building. Also, if let's say I have to build n new buildings, my ID starts with 1. So now that we've, went through the question in short, let's go to the rules. So we have 3 rules. The first says that the height of my first building is equal to 0. The second rule says that my height can only be a positive integer or its value can be 0. The third rule says that if I have adjacent buildings, their height can differ by at most 1. So what does this mean? It means that let's suppose I have a building with height h. Its adjacent building could have 3 possible values: h minus 1, h, or h plus 1. Now we have this slide where we have taken an example. So this is a restrictions 2D matrix, which is like building 2 can have maximum of 1 height and building 4 can have maximum of 1 height. Okay, and my n is equal to 5. So let's mark this constraint here. So it basically says that my building 2 can have a max of 1 height and my building 4 can have a maximum of height 1. So this is my constraint actually. This does not necessarily mean that my building 2 and building 4 would exactly need to have the exact values written here. It just means that my building 2 height should be less than equal to 1. Same for building 4. So now we are moving on to the intuition of the problem. The first intuition is that there are restrictions and restrictions can affect each other. How? Let's say I have been given restriction like my height of building 2 will be less than equal to 1. Right? So we've marked that here. Then my next restriction says that my height of building 4 is 10 initially. Okay. Now let's say from building 1 I am maximizing the building height. My rules say that my adjacent height could differ by max 1. So what would be the height at 3 that I could possibly get? It is 2. Now what could be the height at 4? Since a building length differ by 1 at most, so at max it can go 3. But note here that my restriction says that 4 should be less than equal to 10. But is that really possible in real life? Is this realistic? Can we ever achieve 10? If my height of building 2 is 1. No, we can't. Max we can achieve is 1 to 3. We can go height 2. And then 3 to 4 we can go height 3. So that is what we have done here. So that's why we have updated the value of building 4 to 3, less than equal to 3. Because that's the maximum height we can go. We don't want to keep unrealistic expectations. Okay, now to approach this problem, we have divided the problem into 4 steps. The first step says that there are some hidden restrictions in the question. So we have to adhere to that. Okay, what's the hidden restriction? Let's see. So here my first building height is 0. That was given in the question, remember? So that's why we have added building 1 restriction can have a maximum height of 0. Okay. Now my last building can have a height of n-1 without restriction. How did we come to this conclusion? This was not given in the question, but we have come to this. Okay, let's see how did we come. So basically, let's say my maximum height of building 1 can be 0, right? That's the maximum we can go. And what happens if there were no restrictions? If there were no restrictions, how would height change? So we can go maximum of height difference of 1. Adjacent cells can have height difference of maximum 1. So here when we go, we have height difference of 1. Now from 2 to 3, if we go, we can have again a height difference of 1. Now my from 3 to 4 again the same thing, and from 4 to 5 again the same thing. So we see from 1, if my height is 0, 2 has a height of 1, 3 has a height of 2 if there were no restrictions. Fourth building has a height of 3. What about fifth building? 4. So we can see if my height is n, my last height could go till n-1 without restrictions. If there were no restrictions, this was how it would look like. So we have added hidden restriction. Now we come to the part where we see why did we do this. So we basically have checkpoints. So this is like the lower checkpoint, which is height of 1 is 0, and then this is the end checkpoint, height of building 5. So we have a boundary here so that we know in which range we have to go. That's why. Now if we had no restrictions, this is how height would change, as we have seen in the previous slide. Okay, now there's one thing to note. Let's say I'm standing at this place, building 1. Okay, and the restriction is only on building 1, which is like height, it has height 0, and then we have no restrictions. So what would be the maximum height possible at any particular place? So here my previous height is 0, right? And I am one step away from this location, from this building. When I look at building 2, I am at one step away from building 1. So then what is my distance? It is 1. What is my previous height? It is height of first building, which is 0. So my max possible height for building 2 is 0 plus 1, which is 1. We see it's 1. Same for building 4, 3 and 5. So let's take an example of building 4 here. So when I'm standing here and I look at building 4, we are 3 steps away, right? And what's the previous height? It's 0. So 0 plus 3 is equal to 3, and that is the maximum possible height of building 4. So that is how my height changes. So take a note of this formula. Okay, now we come to the forward pass, which is a step 2. So what's the motivation? We know that our boundaries affect each other, restrictions affect each other, and here we'll see how each restriction affects the other restriction. So we are going to move forward. Now in this pass, we have taken this example where we have, this restriction array with like, we are going to have 2 pointers here. We have previous and we have current. So I'm at my current, second building right now. And I have this rule for forward pass, which is like my second building has some height right now, which is current height. Now from left, which is like from the left last seen restriction, what's the distance? It is 1. And what's the previous height? So it is 0. So 0 plus 1 is 1. So my building 2 can have maximum of 1 height if I have a look at this from left side, left restriction. So, and my current height is also 1. So minimum of 1 and 1 is what we will take, and that will be the height of second building. But why did we take minimum? Let's say, just assume that from left side, my distance was from left side, let's say I had, building 1 had a height of 1. Just giving an example, it's not the case here. And my distance was 1. So now my left side restriction says that I can, if I have to maximize the height, I can make this 2. My second building height could be 2. But this is an example. But my other restriction says, which is like some restriction previously, says that it can only be 1. So in restriction, the building with lesser height will be given more priority, because someone has already told we can't go beyond 1 for second building, right? So that is the reason why we have taken minimum. Okay, now we'll move on. We'll move our pointers by 1 step forward ahead, and then now I'm at 4th building in the restrictions array. So now my height of 4th building is what I'm calculating. So my height of 4th building currently is 1. So this is the current restriction. Now from left restriction, the left restriction, which is 2, building 2, which is a height of 1, and my distance from building 2 is 2. So what's the maximum possible height if I look this way? Like 1, I could have gone, 1 step, incremented 1 here and incremented 1 here. So I would have got maximum height as 3. But my current restriction says no, we can't go beyond height 1 for building 4. So we are going to consider which restriction? The minimum one. So that's why we are going to only consider the minimum one value, which is 1. Now we again move our pointer and we calculate the height of 5th building, which comes out to be 2. Now our current height said it should be 4, but no, it should be 2. From, if I see, height of 4, it is 1, and from 1 we can go maximum of, we can increase maximum 1 height. So 1 plus 1, 2, maximum I can go 2, we can't go 4. 4 is unrealistic. So after forward pass, this is how our restrictions look like. Okay, now we are going to do the same in backward pass. Sometimes what happens is some heights are also need to be seen, some restrictions also need to be seen from the right hand side, like what restrictions do to each other, how they affect. So we are going to move backwards and we are going to do the same thing. So now when I'm standing at 4th building, now what I do is, if from 5 I see how 4 will get. So my 5th building has height 2. So what is the maximum I can go? So I can go 2 plus 1. Adjacent building height can differ by 1, so this can be 3. But my current restriction says it can be 1. So we are going to take minimum of 1 and 3, which is 1. So my restriction at 4th building, restriction of 4th building is 1. Okay. Now we are going to decrement the pointers again and calculate the same height for second building with using the same formula, and then same for first building height. And after backward pass, this is how our restrictions array look, and this is something that we come up to after restrictions array. Now note one thing, that at this point every restriction is valid. So there's nothing we can change more in restrictions part. Now notice a question said that we had to find the maximum height of the building that could be constructed, right? And to find that, just notice that we have just seen how restrictions affect each other. We have not yet calculated the highest building height, right? So we need to do that. So that is our fourth step. So in this step, what happens is, let's say I've taken this example. So here I have this 2. What is 2? It is my second building. So let's say I have 2 intervals. I have restrictions between 2 and 8, second and 8 building. This is like a segment for me. Okay, now what happens is, my height, second height is what? It is 5. And my first height is what? It is 1. So now to find the maximum height in between these these elements. Okay, now what's the minimum? Minimum of 5 and 1 is 1, right? So from one side, what we will do is, we will do +1. We have to maximize the height of the building. So that's why our building 3 will have height of 2. Now from building 3 to building 4, what we'll do is, we'll again increment 1. So what happens? My building 4 has height of 3. Now from building 4 to building 5, we again increment 1. We are maximizing here right now. So my building 5 has a height 4. Now what we do is, we move to building 6, right? And now my height is 5. Okay, now see that my 5 is actually equal to the second height, which was the larger height in between H1 and H2. Now beyond this, if I move one step ahead, I have to somehow again come back to 5, right? So let's say if I do +1 here, it means I have to also do -1 here, because I need to reach to 5 again, and my adjacent building values can differ by 1. So that is why for every +1 after 5, I have to do a -1, right? So I'll come to what I'm trying to say here, but just so you know. So this was how, after reaching 5, we had to go to 5 again here. And how many moves did we have? 1, 2. We had 2 moves left. Okay. Now, how do we calculate the current peak? So, we'll take the maximum of height 1 and height 2. So it is 5 here. So we have taken 5. So we know that up till 5, we are going to reach normally fine, right? And what is my moves? We'll calculate the moves. Let's calculate this. mat.abs h1 minus h2. So what is h1? It is 1. What is h2? It is 5. So what's the 5 minus 1? It is 4, right? Okay. Now from height 1 up till height 5, if I want to go, I have utilized 4 moves. And what are the total number of moves that I have? It is the difference in indexes. Like, what is the difference between 8 and 2 index? It is 6. So I had 6 moves in which I have utilized 4 moves. How many are remaining? 2 moves are remaining. And in those 2 moves, I have to do a +1 and a -1. Then I can increment 1 value. So to find the highest peak, I am going to take the maximum of h1 and h2, and then I'm going to see how many extra height do I have, and then extra height will be move left divide by 2. Why divide by 2? Because for every +1 I have to do -1. That's why. So we've done by 2. So that is how we get the current peak value, which is 6. See, we from 2 to 3 we had 1 move. From 3 to 4 we had second move. From 4 to 5 was a third move. From 5 to 6 was a fourth move. From 6, fourth move. So this is how we have calculated 4. We have exhausted 4 moves by doing +1. We had a total of 6 moves. You can see the distance between 2 and 8. Now, how many moves are remaining? 2 moves. In these 2 moves, we are only getting a height of +1, right? In 2, which means, why? Because for every extra height needs 2 moves, one up and one down. And my remaining moves create a mountain peak. That's why from this height we have added this, remaining moves, which is 1 and 1, 2 by 2, which is 1. So that's how we add 1 to 5. And that's how our current peak value is 6. We also have a maximum, height variable in which we always track the maximum height for every segment. And this was what the 4th step. Find the tallest peak in every segment. Now we come to the code part. So basically this is my step 1. To add new restrictions. And we have to add 2 new restrictions, remember? So that's why we do +2 to the length. And then my first restriction was my first building will have a height of 0. Let's just equal to 0. And what was my second restriction? It was that my nth building will have a maximum height of n-1. It can be less than or equal to n-1. That's fine. And then we have copied all the restrictions. And then we have sorted the restrictions based on the building height. Now we move ahead to step 2. This is the forward pass. This is where we see how our left, restrictions affect the restrictions on the right. So we calculate the distance, and we are going to iterate through the restrictions array, and always we are going to calculate the minimum of the current restriction and the allowed restrictions. How do we calculate the allowed restrictions? We check for d plus, d is the distance of the current index and the previous index, and we check what is the previous index height. So that is how we calculate. Same for backward pass, that is a step 3. And then we have step 4, in which we have a maximum height variable, and then we do a calculation called current peak is maximum height of h1 and h2, and then we add in the total number of moves that we had by calculating the difference between the 2 segment building IDs, and then we subtract the number of moves already completed, and then these are the extra moves that we were left with, and then we divide this by 2 and we add it to the maximum value between h1 and h2. That is how our current peak is calculated. And then we have this maximum height variable which tracks the maximum height for every segment, and then we return the maximum height. I hope I was able to explain this concept clearly. Thank you.